in higher, actually in anywhere. Well, Fedora, since the rest are not here yet, do you have any questions to ask? Oh, don't forget to turn on your mic.
I don't have any questions. I got my WA3 back, and I got, I think, B3. Yeah.
Mm-hmm.
I think like, wait, I don't have my paper with me yet, but I think mostly is like, I think there's one question that they only ask us to give like one amphoteric, okay, like they give us all the choices. Then I think because I put extra, like instead like of putting one per question, this one question I put two, even though my first question was correct, but my first answer was correct, but my second answer wasn't correct, so I didn't get the mark.
Okay, so that was careless. Do you have time to check?
I don't think so, because like like a lot of people was complaining that they didn't have enough time. Then like it's like they had very little time to finish. Some didn't even finish the paper.
But conceptually, any particular conceptual question you have a problem with?
I don't think so. But I
Hmm.
think there was like a few errors like when calculating. Because wait, there was one that like there was one question that I think because there was a 2 in front of all the like the chemical. So for example the ratio was 1:2. Then like when calculating the molar mass, I didn't know whether I had to times 2 or like to the total overall or what. I think in the end had to times 2 or something. Then I got wrong for that question.
Okay, okay, okay. So which topic is your school at right now?
We're doing salts now, I think.
Oh, okay, sure.
Mm.
Did you finish this particular worksheet I'm sharing with you right now?
I can't remember whether we went through, but I think I finished it. It's just that the time when I was doing it, I didn't write my answers clearly. So like now my answers are very jumbled up, and I don't know like which question is for which.
Oh,
Like my working, yeah.
okay. Are you able to sort it out now?
I try.
Hello, teacher. Do you bring this with you? Probably. Okay, somewhere inside.
Last week what?
Yeah.
What?
Yes. How does it? Definitely. Yes. Let's start with that paper 2.
Oh. Oh. Oh, my previous papers.
Previous.
The W2 is still not there.
Oh. That was long ago, right?
Yeah, well, yeah. Ah,
Oh, got it? Huh? No? Oh, yeah. I think you should organize all your newspapers into files.
I don't like far.
You prefer newspapers like this?
I just saw them in the book. How they powerful they go.
You got to organize your stuff.
You know the screen file. Green file school for CV.
You can always use those folder type of files.
Yeah, my SPM doesn't like that.
Huh.
Hey, yeah, so before I did like more fun, he saw my folder, you know, like this state, then he said, no. Because apparently some people screw around in class. Then she tell everyone just to talk.
Oh. Okay, at least you have it. Oh, Fedora, do you manage to find yours?
I have the working. It's just that I don't know like which questions for like which answer. So I'm trying to sort it out now.
Okay. Okay. Tell you what.
No,
She is. She said Lincoln said she's going to do it. Tell you what, for both of you here, I'm going to just go through a few more critical questions.
okay.
No.
No, I said it.
Oh. Okay, yeah, Fedora, try to follow along on your side. I'll just go through some more critical questions. Xinjie, you too, make sure you write down some notes. Okay, first thing first, if I look at this particular question, now they ask for MR. The thing is, this is your MR. Now, this is regardless of any coefficients in front. You do not care about your coefficients at all. It could be 3, it could be 5, it does not matter. MR only pertains to your compound or your substance. So that is all. You should disregard any coefficient in front. So if you look this up, well, you should get this answer. Of course, I may go very fast, but I think both of you do not have any problem at all. So you should get your 6 to 3 here for your MR. Now, likewise, when they ask for concentration, check the unit. Check the unit. Something here, how do I get from this unit to this unit?
You did times to divide MR.
Yeah, which one? Times or divide?
Cannot remember.
Come on, you are going from gram to mole. Therefore, you always divide by MR. Alright, so yes, of course, Vidora, I can't see you, but if you have any questions, make sure you voice out as well. Right, so yeah, I don't think I even want to show through the answer. And this one should be too easy for anyone. Anyways, 2 mole per dm cube. Okay, come. Since you take a look, this one off your head, you should be able to answer this one.
Then
B part 1.
two point five.
Yep, therefore 0.5. Okay, unless you all need me to elaborate, otherwise I can go on. Let me just get this to you. B part 1 can be 0.5. Now, B part 2 is the kind of question you are more likely to expect. So now I'm still trying to get my stuff. Okay, for B part 2. Now, quick reminder to everyone here. Okay. Oh, my stylus is still not working. Guys, try to recognize you have your volume, you have your concentration. What can you calculate based on these two?
No.
Yeah, immediately you should think about number of moles.
The thing is chemistry.
Five.
Okay, guys, give me a moment. Let me restart this particular mirror box. It seems to have somewhat again. You think was it raining outside? No.
I think it's not raining.
Oh.
The bus was sitting there right in front of me and it just flew. That's it. The bus. I think the driver's lying.
He's rushing to go back home.
Yes, it is.
Oh, I never did.
Oh. Let me go and try and do it.
Where was I? This part.
63 goes. Okay.
Now, as I was saying, the part B number 2 is a standard question. Make sure you can. In a moment, let me just wait for the mirror box to start out.
You should get a better route.
Yeah, I know. I should. And 10 are different.
Okay. You want
Do I want to say 1 and 10 are different as well?
to. So you cannot do this.
No, I want, but I can't.
What do you mean?
是你没有钱？
要公司有钱才行哦。
Budget. This is a school.
Volume, All right, this is concentration, and my favorite formula is this: mole equals to concentration times volume. But thinking, what is the thing we have to be careful of here?
You need
Yes,
the end field.
yes, make sure.
Right?
Good.
Oh my god, I just made that mistake.
So you made a mistake. Okay, so by the way, you have 5 moles here of nitric acid.
Oh, I
And
didn't.
since this is 5 mole, here, how many moles of magnesium carbonate do I need?
What is 5 more?
Oh, sorry, I wrote wrongly. Nitric acid is 5 mole.
Oh.
So how much magnesium carbonate do I need? 5. Do you see the ratio here? 1 is to 2. So make sure your answer is 2.5. And don't be careless. Don't worry, it happens all the time, but try not to be you yourself.
No.
Okay, so this is 2.5. Some cheap, I think. All right, part C. This one, you better get it right. What's the answer? 0.5, huh? All right, 2 in 1 mole divided by 2 dn3. I don't think so. I didn't have anything here. So we haven't done this yet. So let's go on. Okay, I'm not going to go through. Okay, maybe I just show the answers for the questions. What volume? Now, come guys, this is too obvious already. They give you the concentration, they give you the what? Mass, they ask for the volume. Come on, what can you do? You can either use this formula, which I already mentioned, or you use and you use the other formula. So yeah, essentially you're just playing around with these two formulas. Anything what answer they get? Yeah. Okay, so I don't think I need to work out everything for you unless you really have a problem.
No.
But just a quick reminder, for volume, try to stick to GMP. Unless the question asks for something else. Because if you don't, you are going to make mistakes sooner or later. Okay, again, same thing. Calculate maximum mass of sodium hydrogen carbonate that can be made from 500 grams of sodium carbonate. Again, once you see mass, you use back the good old formula here. All right, but just for this case, for part B, there is no need to use the concentration formula. That is, this one is redundant because it doesn't involve concentration. You only need to know the maximum mass. So okay, nothing else. There's nothing you can do. You're only given mass. So imagine the first step is obvious to convert this to mole. And to do that, you divide by the MR. But make sure the MR is for sodium carbonate. Okay, so once you have that, let's look at your good old mole ratio. So in this case, sodium carbonate is here. Sodium carbonate is here. And you're interested in sodium hydrogen carbonate, which is over here. Guys, even though it may sound obvious, please don't confuse between sodium carbonate and sodium hydrogen carbonate. They are different, especially for pure. Hydrogen carbonate has a reasonable chance of coming up. All right, okay, make sure you know what is hydrogen carbonate. Thinking what is hydrogen carbonate? Formula.
Just answer the question.
It is, but it should be in your head.
NaCH3.
Yes, that's sodium hydrogen carbonate, but hydrogen carbonate by itself,
HCO3
charge
minus.
minus. All three of you, you're better take note. Has your high chance of coming. Okay, I won't say high, but 50-50. Which also means in your exam, you may encounter funny things like, let's say, calcium, hydrogen carbonate. Make sure you write the formula as such. This can come up. This has come up before. Calcium, hydrogen carbonate. Okay, so yeah, I've already warned you. Oh, by the way, let me show the answer for part E. Anything what you get?
792. But I use concentration. What did I do?
Yeah, what do you do? They just heat the mass. 792 grams.
Yeah, 792. Oh, okay. Guess so.
Okay, good. All right, Laura, if you have your answer sorted out, make sure you should get this 790 grams.
Surgery.
Oh, but I want to emphasize on one point. I think for the two of you, I'm quite confident, but Fedora, you may want to take note. Let us go back to the chemical equation.
Balancing.
What about it?
Yes, of course, you should check whether it's balanced, but in this case, it's already balanced. Now, sodium carbonate is here. All right, and you know that how many moles do you have?
Sodium carbonate.
Sodium carbonate is how many?
4.716981132. So it's 4.72.
4.72, right? Okay, so according to calculations, you have 4.72 mole of sodium carbonate. So therefore, if you want to find number of moles of sodium hydrogen carbonate, you need to account for that coefficient.
Where you get the 4.7?
Yeah, you can really get 4.7.
Because
500.
they said 2 equals to, because the concentration of sodium carbonate is 2.0 and then its volume is 2.36. So I do the concentration formula to get the mole. This one is plus I got 2 and then this volume equal it in so
How come you're doing around one big circle?
I don't know.
Okay, guys. Come on, let me just redo this part. Okay, come. Let's redo this part. Go on.
Another formula.
No, you are still using the same formula, but why do you even go into concentration?
I have no idea.
Okay, stop. Let me do it step by step. Okay, what are you doing?
You still bored. Easy for you.
Too easy.
No.
What's the MR for sodium carbonate?
2 times 33.
106.
Okay.
Based from the earlier part. Okay, so 500 divided by 106. What do you get?
You.
Huh?
No, you got calculator?
500 divided by 106.
4.716.
4.7
4.72.
Okay, let's just stick to 3SF. 4.72.
Isn't the same thing?
Yeah, but why do you go into concentration?
But it's also one sentence, like one.
Remaining no calculator.
You don't need concentration. But let's look at it this way. So 1 mole of sodium carbonate gives you 2 moles of sodium hydrogen carbonate. Alright, so that's the ratio. But here I have 4.72. Okay, so 9.44. So that would be equivalent to 9.44. Yes. And once you know the mole, you want to find the mass, you multiply by ml. But take note, in this case, the ml is not sodium carbonate, it's sodium hydrogen carbonate.
Yeah.
So what is the,
MR
yeah, 84, right?
super big. Yeah, 84.
Super big.
That's like 3 times something. I thought it's very cool.
Okay, so yep, we still get the answer now. 9.44, right? 9.44 times 84. That will give you 792 or 730, depending on your SS.
What have I been doing?
Yeah, that's all. You don't even need to go in concentration or anything.
That's what's correct still.
But I don't think your teachers will appreciate that a lot.
Okay, sure.
Why not?
Because she has the wrong concept.
Oh.
106.
It counts as wrong answer.
Okay, no. Okay, look at part B, this question. Did they mention any concentration at all?
So cannot use that.
Yeah, it doesn't make sense to use any concentration.
That's like
730.
792 point.
That's 730. So it should be 793. How did I get 730? 793. Actually, your answer is close. Okay, 793.
Okay. 22.
Okay. Okay, I think I assume you can follow.
No. This one say 792.
Yeah, it's okay. Your teacher is still give it to you.
Okay.
What's 792?
Oh, because you truncated earlier. Just now you use 9.44. By right, you should use 4 SN for intermediate answer. 5 SN.
I got 792.
Because you didn't truncate it, you use your answer directly from the calculator.
You're good, right?
Yeah, it's good.
That's why I don't like to do. Like to FFE.
Don't bother until you find out the same.
Yeah, you're right. Don't bother until you hit the final answer, then you get to it.
Let's do this. 5A.
5A, we're done already. 5B, volume. This one too easy. No, guys, but anyway, I've done through for all of you. You have your mass. But you can't go from mass to volume unless you have everything in your head ready. You go to mole first. Something here, how to go from mass to mole.
Can you divide them?
How to go from mass to volume? I mean mole to volume, here.
Use for
What's the formula?
divide times 24.
Yeah, times the 24 GMQ. That is all. So I don't think I need to work out for you, but this is the answer. Wishing what again?
8.
Okay, you get 8 EM cubed. And look at the next one, which involves a reaction. Now, guys, even though this question doesn't ask for that, which reaction is limiting?
Yeah, right. I didn't.
Because the question didn't ask for that, but you're supposed to recognize.
Please.
Oh, no need to calculate. It's just
Really?
everything is in the question. No, I mean, which one is limiting?
O2 is it? No, P2 is 6.
Come guys, can I get everyone to highlight this complete combustion of ethane? Once you see this word, you want ethane to be completely reacted. And that already implies ethane must be the limiting reactant. Because, okay, I'll rephrase my wording. For complete combustion to occur, you need excess oxygen. And Jingjian,
No.
write down somewhere, please. That is the implication of complete combustion, or otherwise, how to combust completely without excess oxygen? Carbon dioxide. You're going to have funny products coming out. You can try that.
What?
Like what?
Yes.
Yeah, methane gas or some other funny stuff.
That's
Oh, that's fine.
Oh, that's funny. Yeah. That is not so friendly to you. And you will see this phrase many times, complete combustion.
Actually, right, you see,
Mm-hmm.
if right, no, this one, then you look at the smallest number, then you just assume as the limiting there.
In this case, which is the smallest number? Oh, not necessarily. Cannot.
Oh,
So, so if you want something to be completely reacted, that assumes that that substance is limiting. Okay. And Jingjian, take note of this. You hit more? Yeah. Yeah, come on, Jingjian. You say you go into chemical process in poly, right? You better know this.
physics,
It's physics. I tell you, you go to business.
but you don't teach business, what do I do? Oh, if you got teach, then I'll go.
Business has very limited maths.
But don't like presentation. There's nothing that can do. But just not study, then but
If not go IT, then you get the game, everyday game.
IT.
Yeah.
ITE.
No, information technology.
Oh.
I've heard delivery also got lots, like got high salary.
The provider, you're good.
Provide 4,000, 5,000
Yeah.
every month.
Yeah, possible. They want coding people. Oh, you must be good in coding.
That's weird. I think not. You're not doing anything at all.
What's coding?
Coding.
What's coding?
What's coding? Writing code. Writing computer code. I thought you have done it in your school? No.
I'm terrible at it. I actually just did nothing
Okay, then you better don't go. You better study
because I
information.
hate drilling. So
But anyway, back to this. So, well, 10 grams of ethane, sitting. Come on, once you have your mass, don't think already. Convert to more.
Wow.
Divide by M. This is ethane, not oxygen.
Yeah, 16.
Yeah.
Oh, let's go.
But that's not M, that's just the AR.
Oh.
More of ethane.
Oh.
Then, from more of ethane, you find out how many moles of oxygen you need.
0.
So in this case, you need to use your mole ratio. What's the mole ratio?
I took the pattern.
Yeah, 2 to 7. So therefore, you get it to times 7/3.
What?
Mole Most of ethane divide by 2.7.
Oh, I might do.
Most of ethane divided by its coefficient, which is 2, multiplied by coefficient of oxygen, which is 7. Once you have your oxygen mole, too easy, find out the volume. Multiplied by your 24 dm3. Yeah, get done. Okay. Anything else to answer?
28.
EMQ.
Mm.
Very good. Okay, so 28. Now, units are not in your blank. Make sure you write. Okay, what's the last one? Volume of air. Oh, how to do this?
I just use percentage thingy.
Oh, yeah. Right.
Just math.
Yeah, this is just primary school math. That means imagine oxygen is 21%. This oxygen 8 EMQ. Then in primary school they ask you to solve for 1%. But for you, no need lah. You just go straight to 100%. Because 100% represents air. So what's your answer?
133.
133. So those rock on this kind of primary school math.
Yeah. Did I do what?
Periodicity, your favorite.
Oh.
I think he's a serious one.
What periodic?
He stopped at ammonia. Okay, this year that's it.
Huh? Really? Wait, that all means you still got a lot of time left, no?
1, 2, 3, 2. So something 801.
Just got to revision now.
Then after you want nothing, play.
Yeah, so only not like this next year one.
Then you will die next year. Okay, so is that all done already?
Yeah.
Oh yeah, Fedora, any questions?
Ammonia like nothing on check.
No?
Like, got
No
almost nothing.
questions.
All right, great. Anyway, as I said, this Miro board is available, so you can refer to it if you need to. Okay, come, let's go to periodicity. Yeah, Fedora, get a copy of the periodic table somewhere nearby. Oh, can we make a copy for you?
The periodicity.
Periodic table.
Very accurate.
Yeah, then you use this one. Now your teacher no need to give you a copy already. It's in your head.
No.
Thank you.
Okay. All right, for starters, draw the staircase to separate metals and non-metals. You better get it right.
Yeah.
I found.
So you might as well say it's in your head.
It's here. It's not okay. Here's my pencil.
You go, Fedora, draw your staircase. Don't know.
Anyhow, you do the same thing.
Oh,
Yeah, I draw one.
Oh well, you better though.
wow, exam no fun.
I think they get a highlighter to draw.
The one is here already, I can see.
You can see okay. Well, a Fedora assume you know how to draw. Always start between boron and aluminum. Right down, right down, right down, right down, right down.
Okay, then.
You draw all the way. All the way. You draw all the way.
Okay. You should.
Your test on 117.
Super rare.
Which means they still work.
Okay, my suggestion is in your exam, once you get your exam paper, draw this in unless it's all in your head already. Come, meeting. Which side belongs to the matter?
Yes.
Yes, don't screw it up. Left side will be the matter. Okay, what else do you need to know? No, the other thing is the state of the elements. Now,
Okay.
all gas are
No. Oh, I remember it's only
two liquids. Yes, good. Identify those two liquids.
three and I don't know.
And 11 gases. Identify them.
Nothing.
Mark them down. I'll put L for liquid and G for gas.
No one.
Okay, highlight if you want to. Come, let's play with colors. So let me highlight.
Show us the other liquid.
Oh, you better know.
What?
I don't know.
Forgot already, yeah. They all can be liquid, just heat them. They all.
Well, we are talking about room temperature here. Okay, come girls, identify. Since the boy already knows the answer.
They're the same one.
Come, which are the liquids in here?
Mercury.
Good.
I don't know.
Have you found mercury?
201.
Good.
Yes.
201.
Come guys, or
Document.
girls.
Oh.
The other liquid is bromine. Mark it down.
What the hell? Bromine is liquid.
Yes, you're going to see it sooner or later.
Water.
Probably next year. Could be this year.
How is it?
Mark down. Mark down your 11 gases.
So,
Oxygen.
yeah, no.
Whole column, make sure you all can realize that.
Why is there no symbol for 57 to 71?
Oh, actually now 12 gases. Yes. Yes, anything you're saying?
It says 57 to 71, there's no symbol. Public symbol.
50 what? 57 to 71?
Yeah.
Oh, you don't know?
Put 3.
You don't know?
Why?
You're not down.
You sure that?
Oh, really?
Yes. Yes, it's just didn't write it. Come, Fedora, so this whole row actually fits here. This whole row fits inside there. Yeah, it's not missing, and this whole row fits inside here. And they have a specific name, lantern knots and actin knots, even though you don't have to know them.
No one cares.
We're not tested, right?
No. But let's continue the gases. Done meeting, found all the gases? 1, 2, 3, 4, 5, 6, 7. What else are gases?
What? This.
Carbon.
Oh no.
Good. Nitrogen, oxygen, of course. Don't forget hydrogen.
Oh yeah.
Don't forget fluorine.
Don't guess.
Yeah.
What the hell?
Don't forget fluorine. Fluorine.
Okay, okay.
It can be stored as a liquid, but if at RTP, it's a gas. Oh, well, that's one. That's. So, by the way, you're supposed to remember them, especially for pure.
Oh, what?
Well, the good news is everything else is solid.
Yeah.
Oh, make sure you recognize that one. All else are solid because sometimes in your question they'll mention a solid reacts with blah blah blah. So make sure your answer is one of those solids. Make sure you don't go and choose a gas or something. Yeah, everything else is a gas. I mean, it's a solid. So it's up to you. Maybe once you get your exam paper, you can mark all this down.
What?
Come, this column. Name, Xinqian, this column. Noble gases, which is good. It already tells you the whole column, the whole column of elements are all gases.
Yeah.
17, what's the name? Good. See, I have so much confidence.
No.
Halogens, please remember this term. You will see this in your exam. If you don't know what it is, your answer will probably be wrong. Because you'll ask you to identify. Okay. So let's go and ask me Xinqian.
Hey. I don't remember anything else.
I'm sure you do. Good one. What is good one?
Oh, yes. Let me remember.
Good. Good one are called alkaline metals. Occasionally, this may come up in a question.
Oh, yes, Ben.
So yeah, once they use the term alkaline metals, just search for group one and don't go anywhere else. Group two, thinking.
There's something for group 2.
Yeah.
You should teach.
Oh, didn't teach. Okay, well, that's right. Yeah. Alkaline earth metals.
What?
This is incidents.
Alkaline earth is a bit gray. Occasionally, it may come up, but officially, it's not in favor.
No, the syllabus that's spelled.
Yeah, why not? Your school can be crazy enough to.
Then O level will come on.
Not this term. But there's a reason. What? There's a good reason why you want to remember that because it tells you they are alkaline. In other words, the oxides and hydroxides of these two groups are alkaline.
No, I forgot. But
Yes, these are all the basic oxides and basic hydroxides from these two groups. Okay, next, how about this whole chunk here? Groups. Excellent. Transition elements. Which you ought to know. Okay, and okay, let's see. Let's give you a few questions here.
hey.
No problem for you, nothing.
Oh. What character? Wow.
Okay. Maybe I pull this out too early. Let me just do something else first. Now, guys, a few trends you ought to realize. As you go from left to right, what happens? Okay.
Increasing
Increasing.
valence electrons.
Okay. Increase number of valence electrons. But they're not like you last time. Now instead, make sure you realize that metallic character decreases.
What does decrease?
That means they become less and less metals as you travel from left to right.
Oh,
But occasionally they can rephrase this. They'll tell you non-metallic character increases. So make sure your English is competent. Yeah, of course. The more you go to the right, the less metallic they become.
they're gonna ask why.
Oh yes. Will they ask why? For pure, perhaps.
What's wrong with them?
But before we go to that, let's go to another trend. Draw in your periodic table. Now, as you go down the group, what happens?
I'm get bigger.
Number get bigger. Come, as you go down the group, metallic character increases. And the reverse is true. I don't think I need to write the reverse for you, right?
They call character.
They behave more like metals.
What if I click properties?
Oh, this is for
Now, the most important one is group 4. Even though, or group 5, either 4 or 5.
why?
Look carefully.
Um,
Is carbon a metal or non-metal? Yeah. Carbon, metal or non-metal?
None.
Yeah, non-metal. Silicon? Non-metal, yeah. Alright, but once you heat germanium, it's a metalloid, it becomes like a semiconductor. It's somewhat between metal and non-metal. Tin is a metal, lead is definitely a metal. So this is very obvious for group 4 and group 5. As you go down, you get metals.
Group 4 is 4 plus, right? No,
oh,
Or
not
group 14.
four. Yeah,
Group 14.
4 plus, right?
4 plus.
Did you do you use plus? Plus is not common.
Because teacher say group 3 and 4 is usually
Oh. Did she use plus?
use plus. This is the question that I put mine to say I'm wrong, it's usually plus.
Plus or minus, what the hell?
Just use group 14, or that'll be the safest. Group 14, group 15.
Whatever.
Yeah, I will use 14, 15, 16. Just to suit your syllabus.
I prefer the old.
Yeah, of course, it's easier because the current set 4, they only have group 4, group 5.
Oh,
They don't use 14, 15.
15. Okay.
Okay, but anyway, same thing for group 15. Oxygen, non-metal, sulfur, non-metal. But you go further down, polonium, definitely a metal. Okay, so yeah, that's what I'm trying to say. That's all. Okay, now what else do I need to tell you? Let's go back to my questions. Oh, disappeared. Yeah. Just now Minty was asking. So why does metallic character decrease across the period, left to right?
because they went on method, so it starts.
For the metal, what is the characteristic of a metal?
So valence electron. Oh, increasing.
Yes.
Decreasing.
Okay, let me give you the official answer. Alright, basically a metal likes to lose electrons.
Oh, okay. So what? Right.
Okay, so metal tends to lose electrons.
Oh, look at this, likes. Wait, you say like to lose electron or can?
Let's be a bit grammatically correct, so can. It's not. We are not using personification.
This literature.
Yeah. A non-matter tends to gain electrons. That is what you should remember.
Was there an arcade here before?
Okay.
Yes.
Yeah.
God.
Yeah. Now it's gone.
Then I bought the tickets, but I didn't use it. So I was like, I can come back play later. It's still in the house.
You bought that when long ago.
Yeah, no.
There goes your money. All right, so yeah, that answers the question. Basically, towards the left, the elements tend to lose electrons. When you go towards the right, the elements tend to gain electrons. Of course, let me put it nicely for you. Basically, tendency to lose electrons decreases from left to right.
Ask this.
They may for sure.
MCQ.
For sure, they may.
MCQ look at which one the most logical, then you just choose.
Come, number 2. This one, no problem. What's the same in this period?
Electron.
The electrons.
Thing in each period.
Yeah.
Just
What?
Same one. Same valency.
Ah. Let's see.
Yeah, maintains period.
number of electrons.
Yes, number of electron shells. Make sure you know the answer. This can come up. All right, same number of electron shells.
Forgot all the earlier chapters.
You forgot.
Do you remember the properties of alkaline matter and all that?
Yeah.
You don't say that.
Or
She's aiming to get A1.
properties that occur in ether. Turn rate, litmus paper.
All right, yeah. Oh, okay, I didn't write that, but I assume you all know, make sure you know same number of electron shells and electron shells here. Counting tail,
What?
group 0. Okay, now they call group 18 already.
Okay.
Why are group 18 elements unreactive?
The shell full.
Okay, good. Fully filled valence shells. And therefore, sometimes your teachers will want you to write it's a stable electronic configuration. 2 marks, 今天 better write everything.
听你的挺好的，哎。那我
Come, Fedora, number 4, I shall ask you, why are there 2 elements in period 1, 8 in period 2, and 8 in period 3?
I don't know. Wait, period is
Period.
is row.
Or-
It means hydrogen.
Yeah, how come period 1 only has hydrogen and helium?
Cause they're gas. I mean isn't it they only have very little.
Well, anyway, the answer goes back to electrons as well. So basically for period 1, all right, the shell 1, number 1 shell can only take 2 electrons.
Like not have any electrons.
Okay, but it won't be an element already. I mean, it will be an ion already. So you should be able to deduce the rest. Period 2 or shell 2 can only hold 8 electrons.
What's the hydrogen thing again? Hydrogen can lose and gain and donate electron.
Yeah, okay.
Only hydrogen can donate electron, right?
Others can as well if you force them under the right conditions. But hydrogen can do that more easily than others. Hey, you, yeah, give electrons to someone else.
Yeah, then you lose electron, does it also give?
Donate and lose have the same meaning. Okay, so yeah, that's all I shall say for now. Period 3, I won't say anything. Okay, so take note of these two rules. Shell 1 can only hold 2 electrons, shell 2 can only hold 8 electrons. But let's just touch on the hydrogen that Minking mentioned. Yeah, hydrogen is very unique, and of course it can come up for you.
It's the TYS.
Oh yeah, not surprised.
They just like it so much, like just because it's like
So just take note. Okay, so hydrogen can lose electron. Of course, it can only lose one.
It lose two.
Yeah?
Lose at both.
Both?
Two.
Two. How to lose two?
No.
It only has one electron when it's neutral.
No.
Huh? So once it has lost one electron, what does it become again?
I don't know.
H plus.
Huh? H plus. Your hydrogen ion. Yeah. Make sure you know the name.
I said H plus.
Yeah, I know. I'm referring to them. I have no worry about you.
Huh?
So if they use the term hydrogen ion, it means H plus. Don't think of anything else. But for pure especially, your hydrogen can gain one electron.
Yeah.
And it becomes
Minus.
yeah, what is it called?
Hydrogen ion.
So once it becomes H minus, it's called hydride ion or hydride.
Huh? That was hydrogen.
Do I have to memorize this?
Yes, it can come up. Hydride, you need to know what's hydride. Oh, and just to give you a few examples for hydride. Again, it may or may not come up. Right. The common examples is lithium hydride or sodium hydride. Okay, you can have that.
Boss. Never see me.
Oh, never. Okay. Then you better hope it doesn't come up.
But it sounds complicated.
Okay.
Like you shut up, what?
I can go give him a slap.
I'll beat him up.
All right. Any questions, anyone? Fedora, any questions? Oh, but of course you're not done yet.
Wait.
Yeah, Fedora, fine. Right? Any question? No? Okay, let's go back to our good old friend, group 1.
There you go.
What else, Minting? What else do you know about group 1?
The first group. Oh my god.
I think the low
Go on.
nothing and what? Is it high?
High, yeah.
High.
Okay, that one is subjective. Okay, go on. Now let's get back to group 1 again. We're not done with group 1. So group 1 here.
Why?
Okay, first thing, They are all metals, but they are considered soft metals.
What is this?
So we can cut knives. Oh,
So that they can be cut with a knife.
First there's soft water and hard water. Now there's soft water.
Yeah, they're soft metals. Well, but industrially, the word soft metals is not commonly used. Instead, they call them light metals.
What?
But no need to know
What do we call them?
light metals.
Oh,
So alkaline metals, group 1 are so soft. In other words, they can really be cut with a knife. Soft metals. Mhm. And what else? Their melting point and boiling point are not that high, but we will not go too much into that. Now, what else? When you go down the group,
or this other.
density, as you go down, it's theoretic, no? Density increases.
huh? What?
For that one, a bit complicated. It depends on the arrangements.
Yeah.
Yeah, let's go on. Hey, this one you need to remember. Density increases. It has come up many times.
I will try it, sir. Oh, thank you.
So in fact, just give you an example, lithium can float on water. Okay, take note, density increases, but the funny thing is melting point decreases.
What?
Right.
What?
Yes, confidence in you.
No thanks.
Wow.
So once you go down to cesium, cesium can become, in fact, cesium and francium can become liquids quite easily. It is
Which one? The one you put in your hand?
mercury. Mercury is confirmed a liquid.
No, like it's solid, right? Then you put.
Then this one, cesium can be
You like put in the water, then you will boom.
boom,
That one.
boom, then the top few, sodium. Actually, not top few, actually the whole column. Sodium, potassium can do that.
So let's blow up the lab. Let's go.
But the rest are even harder to find. Sodium is hard enough to find already.
Just take sodium for right, then do some bullshit.
Bullshit.
Illegal to buy, right?
Sodium. Yeah.
Chemicals.
Not sure you have a license, you need to have a license to buy. Then that means normally those licenses are only given to labs.
So you own the lab, right?
No, I don't. It's so expensive to run a lab. Come meeting, what else? As you go down the column or go down the group.
Reactivity decreases.
Well, now my confidence is a bit shaken. So basically, as you go down the group, reactivity increases. That means okay. So, but of course, you may ask, what is meant by reactivity? Now, write this down.
Easily, yes.
Yes, react with what?
Other
Acid.
thing.
Could be acid, could be water. Okay, can be water as well. So let's restrict ourselves to acid and water reactivity, but it could be other reactants too, especially acids and water. But let's go further than that. What's meant by reactivity? Essentially, reactivity means tendency to become ions.
Oh.
Tendency to lose electrons. Remember this term? Remember this. This will come in again and again in other chapters. Lose electrons to become ions. 刚进阶 what kind of ions?
Cation.
Yes, good. Okay, that is the essence of reactivity. At least for group 1.
At least for group 1.
Yeah, the other groups have a different definition. So not too bad, right? Only 3. Density, melting point, and reactivity. Only 3. Oh, of course, this can easily come out in your MCQs, especially.
Displacement one.
Displacement. Okay, fine.
Displacement is the distance, but can be negative.
Right.
6.
Okay, come. Let's Fedora, assume you have no questions, let me go on. Let's go to group 7. Okay, yeah, okay. Let's go to group 7. Then you ask the same questions or observe the same trends.
Opposite, right?
Kind of. All right, so for group 7, as you go down the column, I suggest you write all this when you receive your exam paper in case you forget.
How is good well?
I don't write it.
Reactivity decreases. You notice it's the opposite. It's opposite. It's the opposite from group 1. So in other words, fluorine is the most reactive.
Can it explode?
Can it explode? Oh, it can do a lot more things, man. It can alter your DNA.
Oh,
It can go inside your cell and then change the DNA inside.
mutation.
Yeah.
What the hell?
Okay, so by the way, super important. Even though you all have been in Sec 3 for a while, but make sure you realize fluorine exists as F2, fluorine exists as Cl2, Gr2,
Yes.
A2, and theoretically AT2 and TS2.
You're right. So
Yeah,
that means
because
in real life,
nobody has collected a sample of AT2. In
cannot make.
theory, the whole Earth only has a few grams of AT2. Because it's very unstable. A few grams, whole Earth. Okay, anyway, you get the point. So take note, reactivity decreases. Fluorine is the most reactive. Okay, and how about density? Making
Size increases.
density increases.
Why? I thought it was opposite.
Come guys, remember what we did earlier? Do you notice gas, liquid, and the rest? What do you think the rest are? Huh? The rest are, of course, yeah, solid, and it goes without saying, gases you have the lowest density, followed by liquid, solids. Density increases down the group. If you remember that, if you remember gas, liquid, solid, you will never get it wrong. Last one, melting point, boiling point. Yeah, okay.
Increases.
Yeah, good. And again, same theory. Gas, liquid, solid. Yeah, of course, the lower you are, the higher melting point and boiling point you have. Obviously, those are the gases at the top, you have the lowest boiling point. But, well, for group 7, just a bit more info you need to remember. Before we go into displacement. Oh, that's a question. Now, if I go to group 1, how do group 1 elements appear? Describe.
Solid, is it?
Yes, of course, all are solids. What else? How do they appear to you? Their metals are they not? Yeah, shiny, silvery. Well, they are soft, of course, as you mentioned.
So you punch it, will make a dent.
Yeah, probably. You use your finger, then you make a dent. Okay, so yeah, they are metal, so they are silvery and shiny. As long as they're pure. But you get the point. Now that's for group 1. Yeah, they are like typical metals, shiny and silvery. But let's go to group 7. Yes. Oh, Xingqie, are you writing this down?
No.
As you tell me you know everything.
The later you zoom out.
I zoom out.
Yeah.
Ah.
Oh, lama. Okay.
Huh?
How does fluorine appear?
I think there's a specific thing for this, right?
Yeah, yes.
Is it pale yellow something?
Yes, excellent. Pale yellow gas.
P.
I don't remember the rest.
Then you get fluorine in that.
In the lab can.
Then you just obtain.
No, fluorine. Oh, sorry, I was thinking of fluorine. No, fluorine not so easy. Fluorine, well, greenish yellow.
The gas.
Yeah. I guess I remember we already established that at the beginning.
So it can be good.
Oh, can be, but it has to be under pressure. So yeah, you can call it greenish yellow or yellowish green. Up to you. Bromine.
No, no.
Good guess. I suppose they reddish. Liquid, of course. I think I mentioned it, so I won't write down that anymore. Yeah.
So what is called bromine? Like brown.
Oh yeah, good. I need to remember. Reddish brown. Remember bromine. They like to ask about bromine. Because the color is very obvious.
Oh.
Okay.
Brown.
Okay, it's tricky. But let's stick to the model first. It's a black solid.
Yeah. Yeah, you still got mouth.
Got Astatine, as I said, nobody has seen it before because there's not enough amount to go around, but probably black.
Which is purplish.
Oh, no.
Which is
Later,
purplish.
It's purplish.
I think the TYS and then I thought purplish.
gas, liquid, or solid.
Yeah, it's question out.
This blue one. I mean this color one.
So theoretically, they should be black.
Question out maybe.
No, it has come up before. They will ask the question. They will ask you, what do you expect the color of astatine to be?
Expect more. I mean, this words.
Because nobody has seen it before.
It's never seen before. Test book, but
Oh, then you're supposed to predict.
we did, so we are all scientists.
Yeah, you're studying science at least.
Yeah,
All right,
yeah.
here, yellow. Okay, that looks better. Okay, so what does that tell you? It means the color intensity increases down the road. Come right down. Occasionally they ask.
Wait, do they form colored compounds?
Do they form color compounds? Most of the time, no. Oh, I think I do not need to remind you. You have to remember the colors. But let's address Minty's question about iodine. It's the worst. Yeah, Shidora probably can see, but I didn't share iodine. This solution, does it even look black to you?
Oh yeah.
It's purplish.
Hi, purple.
No. Yeah.
What?
Does it look purplish?
Wow.
Pour.
Yeah, on hand.
Yeah, you can pour on your hand.
Oh, I think too much.
It's okay. You stain your skin for a while. Yeah. Okay. Fedora.
Fine.
Not sure if you can
Not
see
purplish.
this, but basically it's a brownish kind of solution.
Yes, purplish.
Because theoretically it's purplish.
Okay, come right now. Since she's asking about this iodine.
Smudge it.
It's not a skincare product.
It's for your mouth.
Okay, come, let's write down iodine. This is very interesting. In its pure form, it's a solid, and remember, it's a black solid.
Do it after.
It's like it's a crystal,
The copper blocks.
copper dioxide. Yeah, but definitely you can tell the difference. Black solid, but once you vaporize it,
Oh, that's the purple.
that's the purple thingy.
Wait, should I go wash my hands?
Oh, okay. All the highlights.
Brown.
But it has a bit of a solidity in water, so it can dissolve in water. And it's brown.
It'd be
It can be somewhat brownish.
what?
Yeah.
It's not dissolved water.
No, it's not. It's not. That's the second thing I'm gonna go to. It's not in water. It's in water, but it's more than just water.
I'm not sure it expired.
That's why, yeah.
It expired this year.
That's why don't use for mouthwash.
Okay.
But it can also be dissolved in alcohol. So it's quite versatile.
Hey, it's not
Then guess what? It's still brown, which is what you see here. This is actually alcohol plus water.
Yeah, you did mention that last time.
Yeah, I did. But that's not all. If it's dissolved in something else, yeah,
Wow.
in something like hydrocarbons.
The hell is hydrocarbon? Oh, we know that one.
And one of the favorite solvent is hexane. Then it will appear purple. Okay, so just keep an open mind. Iodine can have many different colors.
So can you remember carbon? I mean not carbon, brown.
Yeah, carbon is brown.
Oh.
Carbon is black.
Nothing though.
Oh, you managed to get rid of it.
Nothing.
Oh, okay, good. Okay, I'm meeting. This is fun with iodine.
You'll be tested.
Once in a long while.
Oh yes. Color.
Because they will tell you an observation. In this experiment, a purple vapor is produced, then you may want to suspect it's iodine. But if you think that it's too much trouble, then just forget about it. And then pray that it doesn't come out.
How do you memorize all of this?
You don't.
He's going to pray that it doesn't come out.
Screw it then. Like, how many chapters? 20 plus.
Yeah, only 20 plus chapters.
Only?
Yeah, only.
The
This is for one subject only. For us,
we have different brains.
we see it's very big.
Bigger head means doesn't mean bigger brain.
You sure?
You say what is small?
Huh? Actually,
Yeah.
well,
Yeah.
oh.
Okay, so
Done, huh?
Yep.
Okay, let me see anything else I missed out. Drag case, you're done. Okay, lastly, just also a reminder, make sure you know the gases, except for noble gases, are particularly diatomic. This one you better don't screw up. Nobody should. Nitrogen and
Hockey stick
oh yeah.
and ball.
If it helps you to remember, sure.
So my
O2. And of course, H is H2. Never screw up on this.
H3, H4.
Okay? Or anyone screw up on this, no mercy. Okay, let me see. Anything else I need to remind you? I'll go through the displacement part next week.
Sure. Just say it's distant negative. Okay, negative.
Okay, I think I cover what I want to cover, everything except for the displacement part. Okay, but just to make a long story short, just write down one word or a few sentences about displacement. Yeah, a few. Because 100% coming up.
yes, yeah.
Displacement reaction. Long time ago, I think I did tell you all the different types of reactions.
You
Okay, maybe not.
what not I did already.
Never mind. Assume I didn't say that. But displacement reaction. Can please remember this word displacement? Because 100% coming up. Just that you don't know which one is coming. Anyway, the theory is this. More reactive substance. So okay, let's make it for you. You have either a metal or a halogen.
What? Oh,
Displaces less reactive metal from this compound. Okay, but some schools or textbook will write from its salt. Okay, that's the general rule, and that's what you need to write for your answer sometimes. Not, yeah, go on. The other possibility is it can also work for halogen. Just to give you an example, since Singapore was asking about that. Okay, make sure you remember this. So let's say I have sodium. Potassium. Pure potassium. Then on the other hand, I have sodium chloride. What will happen? A reaction will happen. Make sure you know what will happen next time.
Yeah.
Okay, so recognize this is a displacement reaction. Recognize this is more reactive than sodium. Of course, recognize this is a sodium compound of sodium. And basically, the more reactive it is, it likes to, or it tends to become a cation.
You're saying you can add an
The conditions are right. Okay, just a few here. How many? 10 points, 11 points on it.
Yeah, then you worry about
Long way to go, man.
future education. Go uni every day for student loan.
Yeah, student loans. You go polytechnic also got student loan. Okay, but I missed out one thing. Let's go back to group 7 for a while.
You know, for your student.
Okay, but I just want, can you just add this in? Just now I mentioned about group 7 reactivity.
Student loan.
What is student loan?
Student loan.
You borrow money from the bank to pay for your school fees. But no worry, your dad is rich, you pay for everything.
I think I need it.
You know, okay, your mom is rich too.
No, she's not.
Reactivity. Can you just add in for reactivity? Can you just add in? Yeah, what's meant by reactivity is, take note, in this case it's different. The halogen. Okay, sorry, let me phrase it nicely. A more reactive halogen tends to gain. It's no longer losing, it's about gaining electrons.
Okay.
Electrons, or just electron, to become what, Qingqian?
What?
Become what kind of ion?
Oh, and
It's good. Okay, just keep this guideline in mind. What is meant by reactivity of halogens? Okay, I think that's about all I'm going to cover for today. Next week, we'll go into more about displacement reaction. But just remember there's such a reaction called displacement. 100% coming up. 100%. They'd like to ask. I haven't checked it out. Electricity, your favorite? Maybe. Okay, yeah, that's all for today. Fedora, do you have any questions? Sorry? Construction method. Oh, transition methods. Hopefully they won't ask too much. Okay, if not, yeah, that's all for today. Oh, Qingxie, you need to take picture of anything. No need.
yes, yes.
Okay, Fedora, the lesson has ended, so you may leave if you want to.
Thank you.
Actually, quite a lot more. I don't know how you want to take also.
Another half?
Screw it, and then you hope it doesn't come out.
Wait, you got sent a link?
Yeah, just go to the link and do a screenshot. Right, easier for you.
No, don't even use screenshot because the link will be there.
Okay, I suppose so. P1 to all the way to JC.
You need a phone.
You need to go tuition.
You mean the need?
What who's going to teach at such a high level?
1年没有事。uni
Because you just
Huh?
and you can teach you.
Of course.
I just restrict myself to polytechnic can already. We need to high level.
You can teach poly stuff.
Depends on what stuff. Poly has a lot.
Your stuff.
Only my stuff.
I will go if I can.
Poly.
I will go to your house.
Do I?
Sure can one. Oh, but before that, I tell you how many points it is. This topic 5 subjects, 5 points.
9 points.
Yeah, one
1 point each. Wait, no, 5 points.
5 subjects.
L1
9,
after.
yeah, 9 points.
Actually, can
Of course, can. Then you minus off your CCA, confirm already.
See you, Jess.
See you. Go and count.
Mine. Oh, mine. But you 1 mark away, right? They won't let you.
Bye bye. CCA, close the door, then.
Why you want